the second lecture of the solid state. In the previous lecture, we have seen that what are the crystalline solids and what are their types. Crystalline solid, these are the true solids. There are the types. There are the four types: molecular solids, ionic solids, metallic solids, and the covalent solids. In the molecular solids, polar, hydrogen bonding, and non-polar, these are the types. In the polar molecule, there is the dispersion forces. In the hydrogen bonding, there is the presence of the hydrogen bonding. And in the non-polar, there is the dipole-dipole interaction. Then polar, then hydrogen bonding, and non-polar, these are all act as a insulators, and these are the soft. Only hydrogen bonding is the hard. What are the examples? In polar molecule, HCl is an example. In hydrogen bonded, ice is an example. And in non-polar, any molecule is in the non-polar. Then ionic solids, there is the Coulombic forces, or there is the attraction of the electrostatic forces. Then these are the hard and the brittle. Why these are the hard? Because the molecular forces or attraction are the strong. These are the conductors in the molten state and insulators in the solid states. Examples are the NaCl, MgCl twice. Then metallic solid. In that metallic solid, metallic bonding is present. These are the hard, malleable. They have the ductility and the malleability. Ductile means they can convert in the sheets. Malleable means they can convert in sheet. And ductile means they can convert in thin wire. These are the special characters of the metallic. In the metallic bonding, they can be conductors in molten state as well as in the solid states. They have a very high melting point because their force of attraction is very strong. Then in covalent, in that covalent, these covalent are also known as the network solids. These covalent molecules are also called as the network solid. And they form the covalent bonding. These are the hard, except graphite is only soft. Then they are very hard, melting at the boiling point. Sorry. Examples are the silicon oxide, diamond, silicon carbides, graphites. These are the examples. And that covalent solid, exception is the graphite, because graphite is the good conductor, remaining all are the bad conductors, or we can call them insulators. Then today we are now going to learn the crystal lattice, unit cells, and Rayleigh lattices. What are the crystal lattice? Crystal lattice means there is an arrangement in the 3D. This is the crystal lattice. What is a unit cell? In that crystal lattice, small part is repeated. This is called as the unit cell. For example, suppose this is the cube. If this cube is divided in 8 different parts, if this cube is divided in 8 different parts, then we get a small parts of the cubes in that crystal lattice. And in that crystal lattice, when we get a small part of the cube, then it is termed as a unit cell. I have written here small portion of the crystal lattice, which direction is repeated in different. This is the unit cell. Then how unit cell is classified? Unit cell is classified as primitive unit cell and the centered unit cell. Primitive unit cell is classified as in the 7 parts. As in the 7 parts. Which are the 7 parts? कार्बन, टॉर, बनाया है HMT कंपनी ने. This is the mnemonics to remember this. कार्बन, टॉर, बनाया है HMT कंपनी ने. C for the cubic. What is C? It's C represents the cubic. T for the triangular. T for the trigonal, or we can say this is the tetragonal. Tetragonal. O hexagonal. M for the monoclinic. Monoclinic. And T for the triclinic. What is the trick? The trick or mnemonic is कार्बन टॉर बनाया है HMT कंपनी ने. C for the cubic. T for the tetragonal. O for the orthorhombic. R for the rhombohedral or the trigonal. H for the hexagonal. M for the monoclinic and T for the triclinic. These are the primitive unit cells. These are the 7 types. And in that centered cubic unit cell, there are the 3 types. Which are the 3 types? First is body centered. Body centered. Second is face centered. Face centered. And third is end centered. End centered. Sorry. Body centered, face centered and the end centered. What is the meaning of that primitive? Primitive means on that lattice only corners Then we have to, there's some number of the unit cells. Number of the unit cell. Number of the unit cell. Number of the unit cells. Then further, next classification is ages, and next is angles. Next is the angles. Before going to that table, in the unit cells, there are the 6 parameters. In unit cell, there are 6 parameters. 6 parameters. That is alpha, beta, gamma. Alpha, beta, gamma. Alpha, beta, gamma. Angle between B and C. Angle between B and C is the alpha. These are the definites. So angle between B and C is alpha. Angle between A and C. Angle between A and C is the beta. And angle between A and B. Angle between A and B is the gamma. These are the some parameters. How many parameters? There are the 6 parameters. That is alpha, beta, gamma, and A, B, and the C. These are the 6 parameters. Then on that chart, I will write it number of unit cell, ages, and the angles. Here, how many number of the unit cells? In the cubic, there are the 3 types of the unit cells. There are the 3 types of the unit cells. We can remember in the form of the phone number 32, 41, 32, 41. 1 minute. These are the number of the unit cells. What is the meaning of the 3? 3 means primitive, body centered, and the face centered. 3 means which? Body centered, primitive, and the face centered. In all that cases, primitive is compulsory. Primitive cubic cell is primitive in all cases. Primitive is present. Then next is in that 3, body centered, and then face centered. Body centered and then the face centered. In the 2, here body centered. Here is the body centered. Body centered. In the case of the 4, there is primitive, body centered, face centered, and the end centered. Primitive, body centered, face centered, and the end centered. In 1, only primitive. In 2, here body centered and the face centered is present. Body centered and end centered cubic unit cell is present. And in triclinic, only 1 primitive cell is present. How we can remember ages? Ages are very easy to remember. We can write ages. First, A is to B is equal to C. Then in second case, one parameter is unequal. A is equal to B is not equal to C. In that next case, this parameter is also unequal. A is not equal to B is not equal to C. This is the pattern. Then in rhombohedral, A is equal to B is equal to C. In the rhombohedral, A is equal to B is equal to C. Hexagonal, repeat this trend. A is equal to B is not equal to C. Then in monoclinic, A is not equal to B is not equal to C. And in triclinic, here this trend is repeated. A is not equal to B is not equal to C. This trend is followed. How we can write ages? Very easily. A is equal to B is equal to C. A is equal to B, but B is not equal to C. In the third case, A is not equal to B is not equal to C. For rhombohedral, this trend is repeated. First, all are equal. In second case or in second trend, this is one is not equal. In third trend, all are not equal. And that fourth trend, all are also not equal. Then angles. In that angles, first is alpha is equal to beta is equal to gamma is equal to 90 degree. Alpha is equal to beta is equal to alpha is equal to beta is equal to gamma is equal to 90 degree. Then in that second case, same, alpha is equal to beta is equal to gamma is equal to 90 degree. Alpha is equal to beta is equal to gamma is equal to 90 degree. Then from the rhombohedral, 2 becomes equal and 1 become the unequal. 2 become equal and 1 become the unequal. In the rhombohedral stage, alpha is equal to beta is not equal to beta is not equal gamma not equal to 90 degree. Then in hexagonal condition, 1 become unequal. That is, alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree, or beta is equal to 120 degree. In the hexagonal, alpha is equal to, here beta is equal to 90 degree and here gamma is equal to 120 degree. In the monoclinic, then alpha is equal to gamma. Alpha is equal to gamma and this is equal to 90 degree and beta is not equal to 90 degree. Beta is not equal to 90 degree. And in triclinic, alpha is equal to beta is equal to gamma is equal to not equal to 90 degree. Not equal to beta, not equal to gamma, not equal to 90 degree. Not equal to 90 degree. Based on that chart, I have one question for you, which is unsymmetrical lattice in that chart. Your answer is that this is the triclinic, because here edges are also different and the angles are not same. That's why it is the more unsymmetrical. This is about the Bravais lattices. These are the 14 Bravais lattices. If you sum these are the number of unit cells, then you will get the sum 14. 3, 2, 5, 5, 4, 9, 1, 10, 11, 2, 3, 13 plus 1, 14. That's why it is called as the, how many types of Bravais lattices? There are 14 types of the Bravais lattices. In that, 7 are the primitive and 7 are the centered units cells. Then next part is, if you want, you can take a screenshot. Next part is number of the unit cells. Number of atoms in unit cells. That is primitive, body centered and the face centered. First is primitive. Second is body centered. And third is the face centered. In the primitive, the contribution, there are 8 corners. So 8 into 1 by 8. 1 by 8 is the contribution of each particle. So number of atoms is total is equal to 1 in the primitive. If we consider it is a body centered in which there are the corners as well as in the center of the body, in which 8 into 1 by 8 plus 1 body centered, we get here 2. And in face centered, 8 into 1 by 8 plus 6 into 1 by 2. Why we take C by 6? Because there are the phase. There are the 6 phases and each half atom is contributed. That's why it becomes the